Hello friends, in the previous lecture we had discussed about the stress and we very well know that stress is defined as it is the ratio of force to the resisting area. And what is the physical phenomena of the stress? So we know that the stress is always trying to change the dimension. Okay, the main meaning, what tendency of stress? The tendency of stress is trying to change the dimension of the solid component. Why? The solid, we very well know that the solid is a rigid body. Okay, rigid means it is trying to maintain its dimension, trying to maintain its shape. That is nothing but trying to maintain its dimension. So solid itself means body itself trying to maintain its dimension, and this property and this phenomena is known as strength. So every material has its own strength, means different material has a different strength. Stress is trying to change the dimension while the strength is trying to maintain its dimension. And we very well know that the stress and strength always trying to fight to each other. If the stress is less than strength, if applied stress is less than the strength, then the dimension of material will not change. But if stress is greater than strength, then the dimension of material is changed, and the ratio of change in dimension to the original dimension is known as strain. Okay, so I hope you understand it very well. The strain is nothing but change in dimension by original dimension, and when it will happen when the stress created on the component is greater than its strength, and every material has its different strength. Okay, so we very well know that the stress is categorized, and we divided stress into two categories. One is normal stress and second is tangential stress. Okay, so likewise strain is also divided. If the stress is changed, means the type of stress is changed, then the strain created due to this type of stress is changed. Suppose we had a normal stress. We also know that normal stress, we had two normal stress. One is tensile stress and another is compressive stress. Okay, but practically it is known that suppose this is the component and I applied the 100 Newton force over here, and it is tensile in nature. Then the change in dimension, suppose this is the change in dimension, means length of the object will increase, and this is the 2 mm. Practically it is proven that suppose 100 Newton force I applied like this, Okay, means compressive in nature. Then the dimension means this length, this is the original length, and this length is reduced is 2 mm. Means change in dimension here 2 mm increase, here 2 mm decrease, but the quantity of change in dimension will remain same. So in both the cases, if it tensile stress or it may be compressive stress, then the is known as strain created is known as longitudinal strain. Strain. And which dimension is change going to change? Change in dimension means change in length by original length. And this type of strain is known as longitudinal strain. And suppose the tangential stress, nothing but shear stress. When we apply the shear stress on any object, suppose this is the object, and if applied the force like this, means resisting area and the force both are parallel to each other, then the dimension, then the object is trying to bend, and the change in dimension means this angle will change, and change in dimension is here. I can say that suppose this is the delta x, then the change in dimension strain is change in dimension. Change in dimension means delta x, and the original dimension is L. Okay, and we very well known that tan theta is equal to delta x by L. So this is nothing but theta or tan theta. If theta is very small, then tan theta is approximately theta. So this type of strain means strain created due to shear stress is known as shear strain. Okay, I hope you understand this phenomena. Now, let us understand the strength. Strength nothing but trying to maintain its dimension. The property of material which is opposed to change in longitudinal dimension, that property is known as modulus of elasticity, or Young modulus. Okay, so these are the modulus of elasticity or Young modulus is trying to oppose the change in longitudinal dimension of the material, while the properties of material which are trying to oppose the shear stress or change in angular dimension is known as modulus of rigidity or shear modulus. Okay, so in this chapter we had the name of chapter is properties of solid. So in this chapter we had to learn about the modulus of elasticity or Young modulus, or modulus of rigidity or shear modulus in detail, and we will learn it after these lectures. Okay, so we know that the type of direction of force. On the basis of direction of force, we divide the stress into three categories: tensile stress, compressive stress, and the shear stress. But when we apply the force of any component, suppose this is the sphere, I am going to apply the force like center, opposite side, and all directions. Suppose I am going to apply the force in all directions, then not a single dimension will change, but whole volume of the body will change. Okay, so the strain created due to this type of forces is known as volumetric strain, and this is nothing but delta V by V, means change in volume by original volume. And the strength or the property of material which is opposed to change in volume is known as bulk modulus. Bulk modulus. So I hope you understand, and now you can compare physically between stress, strain, and the properties of material or the strength. So I again want to give some information regarding this type of forces. This type of forces is created in the fluid or liquid. Suppose this container is filled up with water, and one ball or any sphere, if submerged in this water, then the water is going to apply the pressure on the ball in all direction. Okay, so these type of phenomena is created in the liquid or fluid. So this type of forces is also known as hydrodynamic forces. I hope now you are able to differentiate between stress, strain, and the strength. So in the next lecture, we are going to discuss about the properties which is responsible or which are not allowed to change the dimension, that is modulus of elasticity or Young modulus, which is not allowed to longitudinal change in longitudinal dimension, the modulus of rigidity or the shear modulus. This property is not allowed to change its angular dimension, while the bulk modulus, which is not allowed to change its volume. So step by step we learn all the properties in very detail in the next lecture. Thank you so much.